All right, so linear word problems have a certain look about them as well. Since linear equations do, linear word problems do. So here's an example of one. Kyle could do 5 push-ups when he was 1 year old. Okay, that's pretty impressive. Every year he could do 10 more push-ups than the year before. That's even more impressive and unrealistic. How many will Kyle be able to do when he is 20? So what makes this a linear word problem? Well, the number one thing is that the amount of push-ups that Kyle can do, they're increasing by a constant rate, right? Every year, 5 more. Every year, 5 more. It never says anything like, and then Kyle had a growth spurt, and that year he could do 55 more. No, every year, Kyle increases, oops, not 5 more. Every year, 10 more. Sorry, I got confused there. Too many tutorials in a row. So the constant rate is 10. I said 5. I'm so sorry. Please forgive me there. So he started out being able to do 5, but his constant rate of change is 10. Every year, 10 more than the year before. So is there another way that we could check to make sure this problem is linear? Because sometimes people, like Miss Overby, can get their numbers confused. And I said, sure. Let's go ahead and say that on our input side, we can put x and y, but we can really know that our input side would be Kyle's age. And on the output side, that would be the number of push-ups that Kyle could do. So in the beginning, or not in the beginning, when Kyle was 1 year old, he could do 5 push-ups. At 2 years old, he could do 10 more than that. So 5 plus 10 is 15. At 3, he could do 10 more than that, so that's 25. So we could take the time and do hoops, and we could see we have a constant rate of change, or we could just look at our table and look at the y column. As we move down the y column, we are increasing by 10. So that is an example of a linear word problem. Here's another example. You've got a gumball tree in your front yard. It gives off 2,000 gumballs in the fall. Your mom feeds it a special formula that will reduce the gumballs by 100 each year. And how many years will it take before there are no gumballs on the ground to step on? So what makes this linear is that the gumballs are decreasing at a constant rate. They're going down by 100 gumballs each year. Is there another way that we could tell just by looking at and talking about it? Absolutely. We could do an input-output table, and we could say, in the beginning, before we started giving this tree its special formula, it would drop 2,000 gumballs, but by the next year, gosh darn it, if it dropped 100 less, and then the next year it dropped 100 less than that. And we can see by looking at the table that this is linear. Okay, so that's it. Just a real introduction to what linear equations look like, what linear word problems look like, and how to find the slope given the equation of the line. Thanks for joining me, and I look forward to seeing you in class.